Hello students, today I am going to take a lecture on entirely different topic, that is mechatronics. Okay, so mechatronics is nowadays an engineering branch, emerging engineering branch, and which is actually the combination of theory of mechanical engineering and electronics. Okay, so the word mecha comes from mechanical engineering and tronics comes from electronics engineering. Okay, so in this particular lecture, I will demonstrate about some electronic devices, for example, resistance, battery, capacitance, and inductance, and their equivalent mechanical running devices, analogous mechanical running devices, so that you will get a feel that how that particular electronic device is working, how capacitor works, how an inductor works, like this. Okay, so that you will get a good feel that how that electronic device is working, because just understanding the concept, instead of just understanding the concept, it's better to get a feel of that concept. Okay, so this is my attempt for this thing. So let's proceed. Okay. So let's learn that how can we compare a system of battery and applied with resistance by the help of analogous equivalent mechanical device. Okay, so this is the battery, and you can see by the help of wires this resistance is applied. Okay, so current flows from this positive terminal to negative terminal, like this. Okay, so equivalent mechanical device is this. You can consider this battery as a pump which is forcing the water to flow this liquid in a circuit by the help of the pipes. You can see through the pipe in circular fashion this water is flowing. Okay. Now what happens in the battery? The potential difference V1 minus V2, you can consider them as the pressure difference between the two ends of pipe. Okay, so this potential difference is responsible for flow of charge, same like that of the pressure difference is responsible for flow of water, flow of liquid through these pipes. Okay, so you can consider this electric potential difference as electrical pressure which is responsible for flow of charge through this circuit. Okay, now this pipe resistance, okay, resistance offered by the pipe to the flow can be considered as resistance, electrical resistance offered by the resistance on the charge. Now more this pressure difference is, more amount of liquid will start flowing. Like same, more this potential difference, also called as voltage of this battery, more amount of charge per unit time, it will start flowing. That's it. Okay, so this is the equivalent mechanical system for this battery and resistance. So this flowing water is equivalent to the flowing charge through this circuit. What is I over here? This is the current. Current means flow of charge per unit time. Similarly, Q over here is the volume flow rate of water, that the unit is meter cube per second. So pressure difference is acting as electric potential difference, and this flow of water per unit time, volume of water per unit time, is acting as flow of charge per unit time, like this. Okay, so like this we can understand this battery and resistance systems. Now I am taking an example of resistances in series. Okay, to the battery you can see one after another the resistances are applied, R1, R2, R3. So R1 is greater than, R3 is greater than R2. So what we see, R1 is highest resistance and R2 is lowest. Okay, so this is the equivalent mechanical device. The battery, in place of battery you can apply the pump. These are the pipes. Okay, now we know this thing that the frictional force, the resistance force offered to the flow of liquid by the help of pipe depends upon diameter of pipe. Greater the diameter of pipe, lower the resistance offered. Okay, so what we see over here, that R2 is least, so I have made highest diameter pipe, that is equivalent to resistance R2, because its resistance to the flow is lowest, and R1 is highest, so this is thinnest. You can see this is the most thin pipe over here, and this R3 is in between, so this is medium diameter pipe. Okay, so what we see over here, that suppose I say from this end, from end 1, 3 liter per second of water is entering, then definitely under steady state ultimately from point 4, 3 liter per second will come out, because mass is conserved. Similarly in this case also, the resistances are applied in series. The charge entering to the system at point 1, suppose I say 4 ampere, it means 4 coulomb per second. Here I took the example of 3 liter per second. Suppose 4 coulomb per second is entering from this point. Ultimately from point 4 also 4 coulomb per second
will come out. So through this circuit, I will remain same. Means the current flowing through R1, R2, R3 will remain same as the water going in and through all the pipes per unit time. It is through this pipe also 3 liter per second, 3 liter per second, 3 liter per second, like this. Okay. So the flow rate will remain same through all the pipes. Like same, the current will remain same through all the resistance. Okay. But in case you apply some pressure measuring device, we know this thing that fluid always moves from high pressure to low pressure. Definitely P2 has to be lower than P1. In case flow is occurring from left to right, then P2 has to be lower than P1, then P3 has to be lower than P2, and P4 has to be lower than P3. Then only flow will render in one direction. Similarly, V2 is less than V1, V3 is less than V2, and V4 is less than V3, like this. Okay. Due to this thing, the current is flowing through these three resistances. Okay, now V1 minus V2 will tell the potential difference, the voltage across this resistance R1. Same like P1 minus P2 will tell the pressure difference across the two ends of this pipe 1. Similarly, V2 minus V3 voltage across the two ends of second resistance, and V3 minus V4 will tell the voltage across the two ends of resistance 3. Okay, so in case you are adding V1 minus V2 plus V2 minus V3 plus V3 minus V4, ultimately you will get answer V1 minus V4, which is the ultimate potential difference to this combination. Similarly, P1 minus P2 plus P2 minus P3 plus P3 minus P4, you will get P1 minus P4. That is the ultimate pressure difference across this combination of pipes. That's it. Now, in case resistances are applied in parallel, okay, you can see three resistances are applied in parallel. This is the battery. Replace the battery by the help of the pump. Now here it is written that R1 is greater than R2 is greater than R3, means highest resistance is R1, so thinnest pipe I have applied over here. R2 medium, so medium diameter, and R3 lowest, so high diameter pipe. Okay, so in this case what we see, suppose I say this pump is ultimately delivering 4 liter per second of water, suppose 4 liter per second. Therefore we can imagine, if 2 liter per second is going from this pipe and 1 from this pipe, then ultimately from this pipe this will be 1, because ultimately whatever flow is going inside through all these pipes, the combination will come out of 4 liter per second. So here if it is 2 liter per second, again if Q is 4 liter per second, through this thick pipe it is 2 liter per second, through this medium diameter pipe suppose it is 1.5 liter per second, then through this pipe will be 0.5 liter per second, because 0.5 plus 1.5 plus 2 gives 4. So ultimately it may be possible that through all the pipes the flow rate is different, but combination will be equal to the amount of ultimate flow rate this pump is delivering. Like same, to all the resistances, voltage difference will be same for all the resistances. Same like P1, P2 is the pressure difference applied on all these three pipes. However, the current through each resistance can be different. So I will be ultimate current flowing through all these resistances will be all in all, which is delivered by this battery, will be equals to I equals to I1 plus I2 plus I3. Same as total discharge by this pump ultimate will be equals to the algebraic addition of Q1 plus Q2 plus Q3. Okay, this is the equivalent mechanical circuit of this resistances in parallel. Okay, now we will understand the working of capacitor or capacitance by the help of equivalent mechanical device. Okay, so there is a device called as parallel plate capacitor. Okay, so capacitor can be of any type. Out of that, this is one type. However, principle is same for all the types. So this is the parallel plate capacitor, which is composed of two plates. You can see this is the left plate and this is the right plate, and both are conductors, generally made up of metals. Okay, so how it works, suppose this is the battery, you can see, and right now this switch is off. This is the plus, this is minus, and when this switch is on, the circuit is closed, what will happen, the battery will start transferring electrons from this left hand side toward right hand side, left plate to right plate. So electrons will start moving. Electron is negatively charged particle, so it will start moving from left plate to right plate. So this plate will become positive and this plate will become negative. So this process will go on, and ultimately with a period of time this process will stop. So in that case, both the plates are saturated with the charge. Means no more charge transfer will take place. Suppose this battery has potential difference. At most potential difference is V1 minus V2. Okay. So this charge transfer, ultimate charge transfer is proportional to this potential difference. Okay. So ultimately, if the plates are saturated with charge, this plate with positive and this plate with negative, no more charge transfer will take place and no more current flow will take place. Okay, so for a short while, the current flow will be there, but after the plates are saturated with the charge, no more current transfer will take place. This can be understood by the help of this device. Okay, you can see these are the two tubes and which are closed at the ends, and the water is filled inside, and air is also there over the water level. There is air, and this is the pump. Right now, here the pump is on, so it will develop pressure difference. So what will happen? The pump will pull the water from right tube and will push toward left tube. Okay, so the level of water is rising, so ultimately this air will be compressed in the left tube and here vacuum will be created. Okay, so this compressed air will give a pushback to this water. So what will happen? This pump is trying to push the water to go inside, however that created pressure will work in reverse direction. So once the force applied by the pump is not sufficient to overcome that pressure, no more water filling will take place, so water flow will stop. So at that time the pump will run, still the water flow level on in both the tubes will be stagnant. Okay, so this is equivalent to this capacitor. Okay, so this battery is pulling the charge from one plate and pushing toward other side. Ultimately when the plates are saturated with the charge, no more charge transfer will take place. However, battery is trying to take the charge from one plate to another, still saturation has come. Okay, so in case you want more water to go inside, then increase the pressure difference by application of more electrical power to this pump or any other means. In case we are able to increase the pressure difference, some more level can be achieved. Like same over here also, if more potential difference is there, electric potential difference or electric pressure difference, more charge can be collected. Okay, now this is a use of capacitor, uh, a particular experiment with the capacitor. You can see that this is the capacitor, this is a bulb in series, this is the battery, and this is the switch. Right now switch is not closed. Now in case switch is closed, what will happen? The capacitor will start charging. So when the capacitor is charging, then it is taking the charge from the battery, so negative charge from this side and positive from this side. So when charge is going from battery to the plate, there is flow of current because charge is flowing. In that case this bulb will glow. So this bulb will glow for a while. Okay, ultimately when the plates are fully charged with that potential difference, okay, no more charge transfer will take place because the plates are saturated. In that case the bulb will come off. So this is the reason that for AC alternating current, capacitor offers low resistance. However, for DC, the capacitor acts as an infinite resistance. You can see for a short while it will glow and ultimately it is offering a resistance. No more current will flow. So in overall, for DC source, this is the DC source in which the plus and minus of the two terminals remains constant with respect to time. A battery is always a DC source. Plus minus, this doesn't changes with time. Okay, that is a DC source. So for DC source, the capacitor acts as an infinite resistance. However, for AC source, okay, what will happen? This is I have applied AC source, AC current source on the plate. So sometimes this right hand side is negative, left is positive, and sometimes right hand side positive, negative. Okay, because in AC source the polarity changes rapidly with respect to time. So in that case, for AC, this capacitor acts as a low resistance or a conductor. However, for DC, it is acting as an infinite resistance. Reason being, you can understand like this. Suppose that this is the pump I have applied, and this is the tube, and water is transferring from right to left tube. Okay, so in case rapidly I am changing the flow direction right now from this right to left, then left to right, like that rapidly. In case I am changing the direction of flow, in that case the flow will not stop sometime from right to left and then left to right. Okay, so flow will always be there, no more stoppage of flow will take place. Like same in capacitor also, in case I'm changing the polarity rapidly, in that case there will be always flow of charge. However, once it is from one side to another, and other time it is from that side to previous side, like this. Okay, so the resistance offered by a capacitor on AC is given by 1 by omega c. Omega is the frequency of AC. So you can see that it is in denominator. So in case this omega becomes 0, means no frequency at all, that means DC source, then the resistance will be infinite. And in case this omega has infinite value, means infinite times per second the polarity is changing, in that case it will offer zero resistance. Okay, so for AC source the capacitor acts as a low resistance, but for DC source the capacitor acts as an infinite resistance. Okay, now we will understand the concept of inductance. Okay, you can see that this is inductance. Inductance is nothing but a coiled wire. You can see this is a coil of wire, and by this experiment I am demonstrating it. So in case this is an inductance, a coiled wire is there, and this is the bulb, and this is the battery, this is the switch. Now what will happen in case switch is closed? So this is a coil of wire, so it will start developing a magnetic field. Okay, so bulb will not glow. Initially bulb will not glow because the development of magnetic field has been started. Okay, so ultimately when full magnetic field is developed, then bulb will start glow. Okay, so it will offer a resistance for a short while, and then it will become conductor. So you can say that inductance is actually inertia to current flow. Okay, means it will impart an inertia to the flow of current. So initially it will resist the current, and ultimately when saturation of magnetic field will be there, then it will offer zero resistance. Okay, so it can be understood by this mechanical equivalent device. You can see that this is the pump, this is the turbine in its casing, and these are the blades. You can see right now pump is not working. Now pump is on, so what will happen? The water will glow like this. Now it will hit this blade. So due to this thing, what will happen? It will start pushing this turbine to make it spin. But turbine has some inertia, so initially it will not run with full speed. So slowly it will gain speed. Ultimately it will start spinning with full speed. In that case, full current, full flow of water will take place. Initially the flow of water will be of a small amount, but ultimately when it will start spinning with its full speed, with its ultimate speed, means inertia of turbine effect has been stopped, then the water will start moving with its full flow rate. Okay, so for DC, inductance offers zero resistance because it, though it offers resistance, but for a short while. Ultimately it will become zero resistance forever once the magnetic field is developed. Okay, now for AC, the inductance offers high resistance. How we can understand this? So what happens in AC? The polarity of this power source will change, sometimes plus and minus, and then minus plus, like this. So in case rapidly I am changing the direction of flow, so sometimes from right to left and then left to right. In that case, what will happen? Sometimes this turbine is moving in clockwise direction, then anti-clockwise. So ultimately full speed it will not gain. It will never gain full speed. So what will happen? Full flow of water will not take place. So for AC, the inductance offers high resistance. However, for DC, there is zero resistance. Okay, so the formula is that in case omega is the frequency of alternating current and L is inductance of the coil, it is in Henry. The unit of inductance is Henry. Okay, then omega into L is the resistance offered by inductance to the AC. So more the omega is, you can see omega is in the numerator. So more omega means more inertia and more resistance, and zero omega means it is DC source, then it will offer zero resistance. Okay, so hope by this small lecture you would have understood about the different electronic devices by their mechanical equivalent device. Thank you.